So today I have here on my workbench a Raspberry Pi Pico, and I want to show something that I was working this last month, that is a port of the .NET nanoFramework to run on Raspberry Pi Pico. So if you want to know more, stay with me. And if you don't know me, I'm Matheus Castelo, an embedded software developer, and here is my YouTube channel where I like to share the things that I am studying and working on. So if you like this kind of content about embedded systems, microcontroller systems, microprocessor systems, embedded Linux, and etc., please subscribe to the channel to continue receiving the content. So as I said, I was working on this port of the .NET nanoFramework, but first this was an experiment, right? I was trying to test Nuttx real-time operation system. The .NET nanoFramework runs on top of our operation system or a real-time operation system. So my idea was to first port it to Linux, a Linux console application, and after that test the Nuttx support to POSIX and use the same port on Nuttx. And the port was very straightforward. The Nuttx really has a really good, a great POSIX support. I made very small changes on the Linux, made some if-def configs to compile it to Linux and Nuttx, right? Also, I'm leaving here on this video, on the description of this video, some blog posts, right? I wrote this in Portuguese and also in English, so if you don't understand my English, my native language is Portuguese, so I also wrote some blog posts here, so I'm leaving it on this video description. So once I have the .NET nanoFramework running on Linux and Nuttx, also I have the possibility to run it on the Raspberry Pi Pico, because we have support for Raspberry Pi Pico on the Nuttx. So I ported, or I compiled it to the platform, to the Raspberry Pi Pico platform, and now I have C# code, .NET code running on the Raspberry Pi Pico. Let me show you guys. I have some samples. These samples are available on the GitHub, so you can go to the .nutx nanoFramework POSIX samples that I was writing some samples here. So I use this PiPico sample here. Let me open this. It's a very simple C# program, right? A cool thing about the nanoFramework is that they are working on this system device GPIO, and they have their own package. Is the nanoFramework system device GPIO, is a package from the nanoFramework guys, but they are following the same API from the .NET IoT guys. So here on the channel I already show the .NET IoT, the system device GPIO namespace running on embedded Linux devices, and here we have the same API, the same namespace. This is very cool, but running on microcontrollers. So what I'm doing here, I'm declaring some GPIO controller. I'm opening the GPIO 25, that is our onboard LED on Raspberry Pi Pico, this guy here, right? Also, I'm opening the GPIO 6, the pin 9 of the Raspberry Pi Pico, that is connected here. The pin 9 is connected here on this switch, on this button, right? So I'm opening this pin here as pin mode input, right? and I'm running this inside infinite while, infinite loop, right? And for each time that we go inside this block, we will have the onboard LED being toggled, right? So if we have the LED state as being high, this will transform the state to being low, and so on, right? Also, I have here if block. This if block is checking the button state, right? So if I have our switch press it, this will be a pin value high, and we will go inside this block and we will write line system informations, right, about the nanoFramework runtime that we are running. Okay, and also making some sleep here, 500 milliseconds between the run. Okay, so very simple top level program, C# program, right? And here I'm using the nanoFramework template with some changes. I commit these changes on the samples repository, right? So I can use it on VS Code because we have the nanoFramework extension for Visual Studio 2019, but not for VS Code. So I write some tasks here and some other stuff to run it on VS Code. But let's build our sample here. Also, I'm not using the .NET framework from my Windows. I'm using the Mono in Linux. So also I can show that it's possible to use this in a Linux system through the Mono complete package. So you can install this package on Debian or on Ubuntu that you will have the same CLI commands. So I will run here on WSL, but if you are running this in a bare metal Linux machine, you don't need to run WSL on front of it, only the nuget restart. This will install the nuget packages that I have here on my packages config. I have this packages here. You can see that the nanoFramework has their own core library that is the MS core lib, right? Because the nanoFramework is a very nano constrained system, and with this only runs a subset of the .NET framework, right? So this use their own Microsoft core lib. Okay. So okay, we have this nuget restored, and now we can run the msbuild. So this you use the solution, the PiPico, the PiPico solution file, and also my CS project file to generate the assemblies. One detail here about the nanoFramework and the template that we are using in nanoFramework is that they have some custom tasks here that is needed for nanoFramework generate the assemblies, right? You can see here copy nanoFramework files, copy back nanoFramework DLLs, because these tasks here creates for us. Let me list here my /bin/debug. You can see that we have, for example, my PiPico executable and also the PiPico.pa. That means portable executable. These are the assemble files that the nanoFrameworks knows how to execute, right? So we need these files generated, and the nanoFramework template generates these tasks from the msbuild, right? So okay, we have all the .pa the portable executables generated for each of the packages or the nuget packages that we are using, and also for our main application. Okay, so now we have to flash our Raspberry Pi Pico with the nanoFramework firmware, and also we need to store our assemblies a way that the microcontroller and the runtime, the firmware, can read it. So we have two options to do it, right? I'm explaining it here on the blog post. One option is through an external SD card connected to Raspberry Pi Pico, and another option, my preferred option, is generate a custom firmware using a Docker image, right? And this is the option that I use here. So I have Docker here on my machine. I create this Docker image, so I can share here my bin debug folder to /nf inside the container. So my .nuttx container generate Pico UF2, right? So in this Docker image, I have a script that you look inside the /nf, and will copy all the portable executables, the nanoFramework assemblies, and you link it together in a custom firmware to the nanoFramework can run it from a ROM FS, right? So this will create a read-only file system with our assemblies, and you link it together with the Nuttx real-time operation system and the runtime. So let's execute this. Oh, I missed is .nuttx. Okay, so now it's running with the correct name. So okay, it's done. Now if I list again here my bin debug folder, you can see that now we have this .NET NF, the .NET nanoFramework .uf2, right? That is our nanoFramework firmware with Nuttx and our assemblies. So now all that I need to do is copy this uf2 file to the Raspberry Pi Pico. Okay, so let's put here my Raspberry Pi Pico in boot mode, right? I have to press the boot cell button, and I have here a switch only to reset the Raspberry Pi Pico, as you can see. Once with this done, we have this storage created, and now I will copy this .NET NF UF2 here to inside this storage, and the Raspberry Pi Pico bootloader, you flash it, you flash the firmware for me. Okay, so we are now running our C# program in our Raspberry Pi Pico. So remembering what we are doing here is a while true, right? As is a forever loop, and we are doing a toggle on the GPIO 25, the onboard LED, right? As you can see, or LED blinking right here, and also we are checking the button state, right? The firmware here creates serial port, and here is listed as COM6. So let's connect to this serial port so we can check the debug write lines, right? So I have some debug write lines here if the button pin state is high. So Let's see, let's press here the button and it's working, right? So it's working. We are running nanoFramework on the system info target name, PiPico, on the platform system info platform, nuget ARM, and on a firmware on string that is the information about our RTOS, the nuget and 10, the version 10 for ARM. Cool, right? We are running C# and .NET on a microcontroller, on a Raspberry Pi Pico microcontroller, right? But maybe you are wonder that maybe I wrote all this in C and C++ and make a firmware to mimic the same behavior here from my C# code. So let's change here this program to prove that we are really running C# on the Raspberry Pi Pico. So let's remove all of this. Oh no, let's remove the while here. I will remain with these instructions because I will continue using the GPIO for the onboard LED and also for our button, okay? But here I will start a new thread. Very easy to create a thread here. Inside this thread I have also infinite loop, and inside this loop I will do the follow. Or LED, or the state of the pin of or LED or onboard LED will be or button read. So if I have the button pressed, the onboard LED will be turned on. If I don't pressing, or if I'm not pressing the button, or LED will be turned off, right? And will be let's do some sleep here, only 10 milliseconds. Also, let's on the main program here, on the main thread, another forever loop, but here I will only make a debug write line with hello microhobby, and here I will sleep for 1 second. Okay, and that's it. So let's compile it. Nuget, don't need nuget restore because I don't change any package. Let's first build it. Okay, so, and now let's execute Docker container to generate our custom firmware. Okay, so it's done. We have a new .NET nf-uf2 file on our bin debug. So let's flash it, or let's copy this uf2 file to the Raspberry Pi Pico. So let's put here the Raspberry Pi Pico in boot mode. Okay, and let's copy our firmware, or custom firmware to the storage. This will flash for us, and done. Let's see now if I press the button, if the LED state change. Oh, it's not working. Why? Why is not working? Oh boy. Okay, I instantiate a new thread here, right? But I'm doing nothing with this thread. I need to start the thread first, right? To my lambda here runs, okay? But this one on the main thread, let's see if this is running. Let's connect here to the serial port. Let me zoom it. Yeah, the hello microhobby is running. So you can see that we are really changing our C# application, but let's fix it, right? We have a new thread here and I need to start it. Yeah, let's start this thread, right? Now let's build it again, but I will not make it manually. I have here on my template also some tasks. The VS Code has this cool feature that you can write some tasks, and I automate the commands here for my nanoFramework template. I have here this option to deploy UF2 that will make the nuget restart, the msbuild, and the Docker to create my custom firmware. All that I need to do is put my Raspberry Pi Pico here in boot mode and execute it. Okay, so it's done. Our firmware was copied and was flashed on our Raspberry Pi Pico. Let me open here the serial port. Okay, we have the hello micro hobby being debugged right lined here, and also let's see if our thread is working, right? If I press here, oh, now it's working. Okay, so it's working. If I press the button, right, the button pin state is being written on the onboard LED. So if I have my button pressed, the LED turn on, right? And if I release here the button, the LED turn off. Okay, so I made another small change here on the code. I added this variable, this integer variable here, to count, right? We are incrementing it inside the while and right-lining it the value here together with the hello micro hobby to make it clear that we have this thread to check the button state and write it on the LED, right? And the main thread that continues running and will debug right line here, the counting, incrementing. So I have it here already running. You can see that it's a while, right? And also we have another thread working. When I press the button, you can see that the code from the thread is being executed. So we have this main thread and another thread that I created on the code. Very cool, running on the Raspberry Pi Pico. Yeah, so I think is it, guys. I really hope that you like this content. Also, it's good to remember you that all that I show here to you today is very experimental work, right? Is something that I'm working on my spare time on during the weekends, right? And also is not an official port, right? If you don't know yet the .NET nanoFramework, it's totally worth it. Here on the GitHub, you leave here on the video description also the .NET website and the GitHub from the nanoFramework group, because they have support, official support for some other targets, and including the ASP32 that is very cool, with totally support to Visual Studio 2019 with breakpoints, debug, and awesome great stuff, right? So totally worth it if you don't know yet about the nanoFramework to try it in the official supported boards. So yeah, it's it. Remember that I'm leaving all the blog posts links on the video description if you want to try it on your own Raspberry Pi Pico, right? Thanks a lot and see you on the next video.